4.3. Basically, this is what f prime and f double prime tell us about f. This is a very important section. We already know what f prime tells us a lot. So f prime gives increasing, decreasing intervals, f prime gives us critical numbers, f prime gives us max min, okay? Now, what about the second derivative? The second derivative, which is the derivative of the first derivative, tells us when the function is concave upward or downward. What does that mean? So here is a situation in which the function is concave downward, and at this point it changes concavity. Or it can be concave upward, and at this point it changes concavity. It becomes concave downward. So this is concave downward. We say it doesn't hold water if you want. And here it holds water, concave upward. So it will give us the intervals where the function is concave upward or downward. What is the second thing that the second derivative gives? It's something called IP, inflection points or point. This is an inflection point. This is an IP, where the function, this is the graph of the function. So where the function changes concavity from opening downward to opening upward. And that is an inflection point. If the function is always increasing, it's possible, right? Unless I can't think of an example right now. So if the function is always increasing, this may be a critical number, but it's actually an inflection point. It's not a critical number that gives a max min, but it's a point where the function changes concavity. Of course, the same idea happens for inflection points. The first derivative has to be positive, 0 or undefined, and negative for an inflection point, or negative, positive. If the second derivative does not change sign, this will not be an inflection point. It is an inflection point if it changes sign from opening down to opening up. Now, when is the function concave upward holds water? When the second derivative is positive. When is the function concave downward? It does not hold water. The second derivative is negative. So here the second derivative is negative, here the second derivative is positive. That's why this is an inflection point. Second derivative is positive, inflection point, and second derivative negative. Holds water, does not. So it's this situation when the second derivative is negative, the function will be opening downward. Okay, and I know we have only 3 minutes left, so let's look at one example. I'll stop, I promise I'll stop, even if we don't finish the problem, or maybe just we should just look at an example. That would be a graph. Okay, so let's take a look at a graph. Oh, I'm successfully logged out. Thank you. I'm successfully logged out. What if I don't want to be logged out? I still am logged out? Oh.
You just have to click return to Cengage.
Return to Cengage. Okay. Well, I guess I better just log myself back in. Okay. As long as I can find my keyboard, I can log back in. Okay, I'm logged back in. Okay. So we'll just look at the graph and then we'll stop. Is it going to happen today? Okay. Okay, so let's take a look at this graph. Use the graph given to find the following. Open intervals on which f is increasing, then that's very clear. So the function is increasing between this point and this point. So between 1 and 3. And it's increasing between 4 and 6. Increasing between x equals 1 and x equals 3. And between 4 and 6. Decreasing between 0 and 1. Between 3 and 4. And that's done. Now concave upward. So concave upward till here. And then downward. Downward. So there is only one point of inflection right here. From opening upward to opening downward. This is the only point of inflection.
And the point of inflection is like halfway in between when it changes.
Not necessarily. In this graph. Okay. So this is opening up and then opening down. So for example here, yeah, they're making it easy on us. So it appears that this, but it could be somewhere here. I'm not really 100% certain, right? It could be somewhere here, and this changes into concave upward. They're trying to help us and find the point, so I guess they mean this. And then
okay,
this.
So for like that exercise, they expect it to kind of be in the middle, but when you like,
but again, it could be the point of inflection could be here. Okay. So for example, here it's concave. See, doesn't really. Yeah, I could say that this is changing here, concave up, and then concave down, and then up. But it could be a little bit further away. Okay. Good. So I just wanted to start 4.3. You're not responsible for anything in 4.3, but please do as much as you can from 4.1 and 4.2.